Hello students, this is our refraction part 3 video in continuation of previous part 1 and part 2 video. In the first part we have uh, discussed about the introductory portion of refraction. In the second part we are going to cover, we have covered in the second part we have covered about the laws of refraction. Now in this part we are going to cover representation of refractive index. Representation of refractive index means in the last part we have discussed about Snell's law, that is laws of refraction. There we have seen that sine of angle of incidence and sine of angle of refraction, sine I by sine R, it's a constant. It's what? It's a constant, and it's denoted as a symbol mu. This is denoted as a symbol mu, which is commonly known as refractive index. Actually, this constant mu is known as refractive index. Now, what is actually refractive index? Now, suppose the extent of change in the direction that takes place in a given pair of media is expressed in terms of refractive index. Now, how we can represent refractive index? Let's discuss all this. So first let me draw again an interface, then let me draw the medium. Okay, medium, and here we will draw medium 1. Now the thing is, this is medium 1, this is medium 1, and the thing is, this is medium 2, and the light is coming, and the light is coming, and then the light is bending. Okay, whatever, the light will come and light will bend. Now we will discuss that how we'll represent the refractive index of medium 2 and medium 1. Let us consider refractive index of medium 1 is mu 1. Okay, and let us consider refractive index of medium 2 is mu 2. No problem. One portion is mu 1, one portion is mu 2. Now understand very clearly. Refractive index of medium 1 is mu 1. Refractive index of medium 2 is mu 2. But how can we represent that? We can represent by a symbol. What is that symbol? That symbol is 1 mu 2. Yes, left hand side I am writing left hand side I am writing this one 1. Right hand side I am writing 2. Remember, left hand side I am writing 1, right hand side I am writing 2. 1 mu 2. What it means? 1 mu 2 means mu 2 divided by mu 1. Now you might be asking, what is this mu 2 by mu 1? What is this mu 2 by mu 1? And what is this 1 mu 2? Now mu 2 by mu 1 is what? Refractive index of medium 2 with respect to refractive index of medium 1. I am repeating it again. When we are writing that 1 mu 2, 1 mu 2 is representing what? 1 mu 2 is representing mu 2 by mu 1, and that is what? Refractive index of medium 2 with respect to refractive index of medium 1. Now let us show you, but drawing. Which kind of drawing? Again that drawing. Okay, yes, again that medium, again that medium 1, and here medium 1 I am writing, and here medium 2 I am writing. Now let's draw a normal. Let's draw a normal. That normal I am drawing. Okay, Now when I'm drawing normal, the light ray is coming. Let me draw properly. Now see here, light ray is coming. As the medium is changing, light ray will bend. Light ray will bend like that. Light ray will bend like that. Now just observe here. The observed thing, the most important thing to observe here is the light ray is coming from medium 1. The light ray, it is coming from medium 1, then it is coming to medium 2. When light ray is coming from medium 1 to medium 2, then we'll write mu2 by mu1. Means when light ray is coming from medium 1 and it is coming to medium 2, coming from 1 coming to 2. So diffraction is happening where? Bending of light is happening at medium 2. Bending of light is happening where? Bending of light is happening at medium 2. Understand very clearly. As the light is coming from 1 and refracted, bent and deviated at medium 2, refraction is happening at medium 2. That's why we are writing mu2 by mu1. And what it is representing actually? It is representing refractive index of medium 2 with respect to medium 1. Means if the thing will be happen vice versa. Vice versa means if the light will go from 2 to 1, then it would be mu1 by mu2. Then it would be mu1 by mu2, the opposite thing. But as it is here, light ray is coming from 1 to 2, we are writing mu2 by mu1, and we can write here mu2 by mu1, that is equals to sin I by sin R. Mu2 by mu1, that is equals to sin I by sin R. That means the refractive index of medium with respect to vacuum is called absolute refractive index of medium. We can take any other example too. Any other example means I can show you. Suppose I am writing W, let me write W mu G. What does it mean? W mu G means you can write refractive index of glass, G for glass and W for water, with respect to refractive index of medium water. See here, at the right hand side I have written here glass G. At the left hand side I have written here water. That means refractive index of glass with respect to water. Refractive index of glass with respect to water. So I can write it's like refractive index of glass with respect to water. One another formula on relating refractive index and speed of light, that is we have discussed already earlier, that mu equals, let me write mu equals C divided by V. Mu equals C divided by V, we can write like that. If we can write A mu G, A for air, G for glass. What does it mean? Refractive index of glass means refraction is happening at glass. With respect to what? With respect to air. So we can write C by Vg. C by Vg means speed of light in air. Speed of light in air divided by speed of light in the glass. Likewise. That's it only. Means if we can write let me write A mu W means refractive index of water with respect to air. Then we can write C by VW. V is the velocity of light in water, C is the velocity of light in air. That's it only. So that's it for today's video. Thank you. We'll be soon with our next video with the numericals of refraction and refractive index.